So this is the review key for the Unit 2 study guide. So I'm going to go through each question. If you need to jump ahead, you go ahead. But I'm going to go through each question piece by piece. All right, so it says define an expression for the width of the shaded region. Well, the shaded region, the width is, the whole thing is this, 8x. But we're taking away these 10-foot sections, and there are 1, 2, 3, and 4 of them. Okay, so what we would do is we'd take 8x, and we're taking away 4 10-foot sections, which is 40 feet. Okay, now we want to define a function a of x for the area of the shaded region. Well, the area of a rectangle is base times height. So if we do a of x, I'm going to write the height first, which is 2x, times the base, which is 8x, minus the 40, okay, which is what we got in part A. All right, next it says, what is the maximum area that the shaded region can be if the width is 200 feet? Well, our width is this, 8x minus 40, so we're going to set that equal to 200. So 8x minus 40 equals 200. All right, we're going to solve that for x. So you're going to do 200 plus 40. Divide that by 8. X will give you 30. Well, that's not our answer. That's just what x is going to be. So now we put that x back into our equation. We got 2 times 30 times 8 times 30 minus 40. So that's going to give us 60 times 200, which gives us 12,000 feet squared. There we go. All right, next one. Michelle is making a poster for the science fair. The posters come in different sizes and have side panels of width x inches. The total width along the bottom of the poster is 36 inches. The height of the poster is 10 by 10x inches. See the picture below. Okay. So define a function a of x for the area of the shaded region where the pictures can go. So again, we kind of do the same idea as we did up top in the last problem. We have a times x, or sorry, a of x. Our height is 10x. Our width is 36 total, but we're taking away these 2 x's. So if we're taking them away, we're subtracting 2 x's. Okay, it says what is the maximum area of the shaded region if the width of the shaded region is 30 inches? So again, we take the width, which is the 36 minus 2x, and set it equal to 30. So I'm going to subtract 36. Give us negative 6 equals negative 2x, so x will equal 3. All right, now we can put that back into our equation, 10 times 3, and then 36 minus 2 times 3, which gives us 30 times 30, which is 900, and we're doing square inches this time. All right. So that's how you do those types of problems. Number 3, consider the function f of x equals x, quantity x minus 2, and x plus 5. Dilate f of x by 2x to create a new function. Okay? So if we're creating a new function, our new function is going to be called h of x. So we're going to write down h of x equals. We're dilating by 2x. All right? And all you got to do is put that right in front of what you've already got, x minus 2 and x plus 5. That is it. For part A, you do not have to multiply it. It does not say, please put in standard form. In fact, part B does not say put in standard form. So again, do not multiply all these things together. It does, however, ask you to identify the zeros. So for the zeros, we're going to take each of these functions, or sorry, each of these expressions in the function, there are 3 of them, and set them all equal to 0. So the first one is going to be x equals 0, since 0 divided by 2 is still 0. The second one is going to be x equals 2, because we're adding 2 to both sides. Last one is going to be x equals negative 5. All right, it doesn't say coordinates, so I'm going to leave this as the answers. You don't have to put them as points. This is good enough for me, right? That's it. Okay. Next, analyze the graphs. Okay. So we're going to make a new sketch of m of x. All right, and to do this, what we're going to do is we're going to put points where our graphs cross the x-axis. So there's a point here, and there's a point right there. Because all that parabola, that blue line does is it hits the the origin, which is 0, 0, and then it goes back up. It does not go through. So we're going to make our little dashed lines, vertical lines, right here and right here to figure out in these three regions, here's 1, 2, and 3, what has happened with our new graph. Okay. So I'm going to change colors to show you this. And we'll get rid of those. So we got the blue line is positive, the red line is negative. So a positive times a negative is equal to a negative. And the middle region at 2, the blue line is positive, the red line is positive. So positive times a positive is equal to a positive. All right, and in the third region, we have a positive and we have a positive. So that's going to be a positive times a positive is equal to a positive. Okay, so let's look at how this works. Okay, a lot of the examples you saw in the other sheets, when we were doing this for practice, they always went through. This one's going to bounce, and I'll show you what that means. Okay, for the first part, it says negative, right? So we're going to start at negative. We're going to go through that first point because the next region says positive. We're going to be positive. But then we got to go back and hit this point. But we're not going back through it to go down to negative because it says the third region is positive. So what we're going to do is we're going to bounce off this point and go back up. We're going to bounce and go back up. Okay? So your graph should look something like the green graph. So it goes up through the first point, goes down and hits the second point, but it bounces off that second point and goes back up again. All right, does not go through it and go back down. Okay? And that's all you need to do is sketch that graph. All right, and number 5, same idea. We're going to figure out where the two lines cross the x-axis. So there's a point here. There's a point here. So we're going to make our little, oops, that's not a dashed line. That is a solid line. There we go. So dashed line there. Dashed line there. So we have 3 regions again. We have 1, 2, and 3. Okay, so let's do our different colors here. So in the first region, our blue line is positive, our red line is negative. So it's a positive times a negative is equal to a negative. In the second region, we have a positive and a positive line. Here's a positive line. And lastly, we have a positive times a negative. Positive times a negative is a negative. Okay, so let's erase my circles here. All right. So, we're going to start off negative. We're going to go through the point because it's going to be positive in the second part. And it's going to go back through the point and become negative again. So this is what your graph should look like. Okay, so we have a negative, a positive, and a negative. All right, based off of the orange signs that we have on the left. All right. Okay, it says consider the expressions x plus 2, negative 4x minus 1, and 2x plus 3. Write a new function, m of x, that is a product of the 3 given expressions. So we have m of x is equal to x plus 2, negative 4x minus 1, and 2x plus 3. All right, now though it says write the function in standard form. That means we have to multiply these 3 functions, or these 3 expressions together. All right, now if you were in the Zoom sessions late last week, all right, I mentioned this a couple times. If you have 3 expressions, you can only multiply 2 at a time. So let's take the first 2. All right, it looks like there are 2 of these types of problems. Okay, so I'm going to do the rainbow method in one and the box method in the other one. So rainbow method comes first. So we have x plus 2 and negative 4x minus 1. So we have x times negative 4x gives you negative 4x squared. X times negative 1 is negative x. 2 times negative 4x is negative 8x. And 2 times negative 1 is negative 2. So I'm going to be having negative 4x squared minus 9x minus 2. Okay, so that's the first 2. Now I'm going to multiply the third one, but I'm going to put it in front. So I'm going to have 2x plus 3. So I have 2x times negative 4x, which gives you negative 8x to the third. 2x times negative 9x is negative 18x squared. 2x times negative 2 is negative 4. All right, the next one, 3 times negative 4x squared is negative 12x squared. 3 times negative 9x is going to be negative 20. I'm sorry, this should have a negative 4x. Negative 27x. And 3 times negative 2 is going to be negative 6. Okay, so I've written them down in columns where the like terms are going to be combinable. So I have negative 8x cubed, all right, minus 30x squared, minus 31x minus 6. And that is the function, but I forgot one thing. Let's erase this line right here. Because it's got a name, the function is called m of x. So make sure you put that down. There we go. All right. Next one. We have p of x. It's going to be 2x minus 1, 3x plus 2, and negative x plus 3. Again, it says to write it in standard form, which means we do have to multiply it. This time, instead of the rainbow method, I'm going to do the boxes. So here we go. So you got 2x minus 1 and 3x plus 2. Again, you can only multiply 2 things at a time. Okay. 2x times 3x is 6x squared. 2x times 2 is 4x. 3x times negative 1 is negative 3x. And negative 1 times 2 is negative 2. The diagonal boxes can be combined to be like terms. So we're going to have 6x squared plus x minus 2. All right, so I have this expression. I'm going to multiply this by negative x plus 3. Okay, so I have negative x times 6x squared is negative 6x to the third. Let me make a line here. There we go. Negative x times positive x is negative x squared, and negative x times negative 2 is positive 2x. All right. 6x squared times 3 is going to be 18x squared. X times 3 is 3x, and 3 times negative 2 is negative 6. Again, the diagonals are like terms. So we're ending up with negative 6x to the third plus 17x squared plus 5x minus 6. And again, this is called p of x, so we're going to put that in front. Don't forget the function notation. And that's it. All right. Number 8, write an example of a cubic function with three distinct roots. Okay, so I'm going to call our function f of x. If there are 3 distinct roots, a cubic function, again, reminder, is a x to the third power. Okay, but with 3 distinct roots, we're going to make 3 distinct factors. The numbers don't make a difference. I'm going to put minus 1, plus 2, and minus 3. There are 3 distinct roots. If you multiply those together, it'll give you x to the third. So that is a cubic function with 3 distinct roots. Number 9, write an example of a cubic function. So I'm going to do f of x again with one root that has a multiplicity of 3. Okay, so I'm going to pick one root, but again, the number doesn't matter, plus 4. Multiplicity of 3 means you see it 3 times. So I'm going to raise that to the third power. So there's one answer that you see 3 times. And that's what it is. All right. The fundamental theorem of algebra states that the degree n polynomial has counted with multiplicity exactly n zeros. Ugh. Okay. Let's say that in English. All right. A graph can have as many solutions, which means how many times it goes through the x-axis, as an equation has degrees. It cannot have more, but it could have less. Okay, so let's look at the how many solutions our graph has. It has 1, 2, 3, 4. All right, our equation, there are 3 separate x's, which means that at most it could be x to the third. That degree is smaller than the number of solutions, which is no good. Okay. So this would be a no. excuse me, the graph has more solutions than the equation has degrees. Okay, so look at 11. We have our equation, or sorry, our graph goes through this point and this point. There's 2 points. And here in our equation we have x and x. There's 2 x's, which is going to be x squared. So since the equation degrees and the solutions of the graph match, this would be a yes. Okay. Graph solutions is 2. Let's not do that. The same as equation degrees. Okay. And lastly here, if we look at our graph, we have 1, 2, 3, 4, and 5. So there are 5 solutions to this equation. All right, based on your equation, you have 1, 2, and this actually counts as 2 because it's x squared. So that means at most you're going to have x to the 4th. So again, you have more solutions where the graph goes through the x-axis than you have degrees in your equation. So this is going to be, again, a no. Graph has more solutions than equation has degrees. All right. Okay, so these are kind of reviews. Concavity, we're looking for the number out in front. Since it's positive, your graph is going to go up. Your x-intercepts are going to be based off of the 2 expressions there. So you're going to have 3, 0 and negative 4, 0. Please make sure they are written as points. All right, number 14, concavity. This is a minus sign, so it's going to go down. Your vertex is h, k. The h changes sign, so it's positive 3 and 9. Your axis of symmetry is going to be based off of your h value in your vertex, x equals 3. And then number 15, your concavity, since this number is positive, it's going to go up. And your y-intercept is based on this number here, so it's going to be 0, 1 as a point. Okay. Here are some solving problems, so it's quadratics and other things. Okay, now for number 16, I see this problem all the time. People want to multiply this together. Please don't. It's already been factored for you. All you have to do is take these expressions and set them all equal to 0. So your first one is going to be x is equal to, we subtracted 5 and divided by 2. Here we added by 3. Here we added 7. These are your answers. Okay. And number 17, there's a couple ways you could do this. You could subtract the 16 to the other side to get a difference of 2 squares. You could also just square root both sides. So x will equal plus or minus 4. Don't forget the plus or minus. There are 2 solutions to that equation. And number 18, you have to get the 3 to the other side so that you can set the equation equal to 0. So we're going to subtract 3. Okay. Now we can do 2 times negative 3 is going to be negative 6. And find out the factors of 6 that will give you negative 6 that give you negative 5. That's going to give you negative 6 and 1. Okay. I'm going to do the bottoms up method. So I'm going to put the 2 from the beginning number right there as my denominator, which gives me negative 3 over 1 and then 1/2. X goes in the bottom, and then that number becomes the first term in my expression. So I have 1x minus 3, and I have 2x plus 1. Now that's not done, that's just the factorization for it. So now I can take those 2 factors, set them both equal to 0, and solve for x, kind of like I did in 16, the one above. So x minus 3 equals 0. 2x plus 1 equals 0, x will equal 3, and x will equal negative 1/2. Next, same idea, we have to bring that x to the other side, so I'm going to have 2x squared. It's going to add x and then minus 4. Set that equal to 0. Okay, so next what we're going to do is 2 times negative 4 gives you negative 8. All right, factors of negative 8, they give you positive 1. Well, there are none. Okay, so that's not going to work. So instead, what we're going to do is put it in the quadratic formula. So the quadratic formula, I'll put that up here, is negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And there it is. So we're going to put those values into our quadratic formula. The number in front of the x is a 1. So we're going to have negative 1, because it was positive in the equation, plus or minus the square root of 1 squared. Notice I put it in parentheses. It's a good habit to have. Minus 4 times a, which is 2, times c, which is negative 4, all over 2 times a, which is 2. All right, so I'm going to figure out what is inside the square root sign. So 1 squared minus 4 times 2 times negative 4 is 33. So I'm going to get negative 1 plus or minus the square root of 33 over 4, and that's going to be my answer. Okay, number 20. Excuse me. We can just simply factor this one. So it's going to be 5 steps to factoring. We're going to have x and x. We have negative 5 and positive 3 are 2 factors. So negative 5 times 3 is negative 15. Negative 5 plus 3 is negative 2. So x will equal 5 and negative 3. And that's it. Lastly, in 21, this looks like a regular quadratic, but there is no c term in this. And what you can see is there's common factors between 5x squared and 10x. I'm going to take the 5x and take out 5x. So I'll be left with x minus 2 when I'm left after I've taken the greatest common factor out of both terms. Okay, so now what I can do is take these two terms and set them both equal to 0. So x will equal 0, because 0 divided by 5 is 0, and x will equal positive 2. That's it. All right, next function notations, composites. All right, so what we're going to be doing is putting these values into the functions you have up top listed. So I'm going to put 4 in for the p function, so I have 2 times the absolute value of negative 4 times 4 plus 3. So I have to do the inside of that first. So negative 4 times 4 is negative 16 plus 3 is negative 13. I'll just show you the work. The absolute value of negative 13 is positive 13, and I'm going to multiply that by 2. So 2 times 13 is 26. Number 23, we're putting 3 in for m. So I have negative 2 in parentheses to the third power minus 5 plus, put 2 in for the k. So I have 1/2 parentheses negative 3 times 2 plus 2 quantity squared. Okay, so let's go through this nice and simply. Negative 2 to the third is going to give you negative 8. Negative 8 minus 5 is negative 13. Okay, plus, we'll do the other side. Negative 3 times 2 is negative 6. Negative 6 plus 2 is negative 4. And then negative 4 squared is going to be 16 times 1/2. Okay, so I'm going to put the negative 13 down here again. And 1/2 of 16 is going to be 8. Negative 13 plus 8 is negative 5. Okay, so for this part, you have to do the inside part first. Then you have to, so this is 1. Then you have to square it, which is 2. And then you can multiply it by the 1/2, which is the third step. Okay. All right, number 24. k, we're putting in negative 2 in for the k value. So we have 1/2 negative 3 times negative 2 plus 2 all squared minus, I'm going to put the whole thing in parentheses just because it's a good idea because I'm doing subtraction. All right, p is going to be 2, the absolute value of negative 4 times 2 plus 3. And then I'm going to close the parentheses. All right, so once again, I'm going to do the inside of the parentheses first. So I have negative 3 times negative 2 is positive 6. Positive 6 plus 2 is 8. And 8 squared is 64. Okay, I'm going to finish this off. So 64 divided by 2, or 1/2 of 64, is 32. Minus, again, I'm doing the inside here. So negative 4 times 2 is negative 8. Negative 8 plus 3 is negative 5. Absolute value of negative 5 is positive 5. And 5 times 2 is 10. So I have 32 minus 10 is 22. Okay, last one of these. Putting 2 in for the m. So I'm going to get negative 2 to the second power, because that's what the m of 2 is, minus 5. All right, and then I'm going to multiply that by, let's put these in both in parentheses to make it easier, or at least organize the information better, p of negative 3. So I'm going to put in 2, absolute value of negative 4 times negative 3 plus 3, absolute value. And close the parentheses. All right, so inside my parentheses on the first part, I have negative 2 squared is positive 4, and 4 minus 5 is negative 1, times negative 4 times negative 3 is positive 12. Positive 12 plus 3 is 15. The absolute value of 15 is still 15. And 2 times 15 is 30. So that gives you negative 30 because you're going to multiply negative 1 times 30. And that is it. Congratulations, you've reached the end of the review sheet. If you have questions, please come to a Zoom. Even if it says we don't have to Zoom today, I'm still there for Zooming. Let me know if you have a question before you take the test on Friday. All right, good luck.